this big, it's not bad, right? You see it from.
All right. So this is where we left off yesterday with quadrants 1 filled out with our sine and our cosine. Which one fits our x-coordinate? Cosine is our x-coordinate. And then which one is our y-coordinate? Sine, right? It's the front cover of your book. Okay. Oh, it's also right up on the board. Duh. All right, so we have our first quadrant. We have our cosine sine coordinates because our radius is 1, right? Of our unit circle, our radius is 1. So any ratio divided by our radius is just going to be that original one. Okay. Now we need to fill in all of the rest of these angles using these as our starting point. So if we look at quadrant 2 and we look at our 30-degree angle, what angle matches the 30-degree angle over here? The 150, right? That's going to be this guy right here. Matches. Okay. Which coordinates are negative in quadrant 2? X's, right? Because in quadrant 2, your sign is positive, right? The ASTC thing is which ones are positive. Okay. So this x coordinate of 3 root 2 is going to turn into negative root 3 over 2 over here, and then positive 1/2, right? Because these triangles are symmetric, just opposite. It is like a bow. When we're looking at our 45-degree angle, which angle matches the 45 over here? The 135, right? Our green line right here. And then of this, what is going to change about this coordinate? X is going to change. So we'll have root 2 over 2. Is that going to be negative? And then our y is positive. Right? And then which angle over here matches 60 degrees? The 120. And then our x coordinate turns negative. Also because our cosine is negative in quadrant 2. So this is going to be negative 1/2 positive root 3 over 2. All right. I'm going to have you pause and go do the same thing for quadrants 2 and 3. Or we have to do it for quadrants 3 and 4, and then we're going to come back and we're going to check our answers. So this is where we're bringing in our reference angle. So 210 is a reference angle with 30 degrees. And so because in quadrant 3, both sine and cosine are negative, we're going to take our sine and cosine from 30 and turn them negative. And that's with that reference angle. All right, so you can check your answer. So one way that you can think about this is that we're trying to find congruent triangles, right? Triangles that are oriented the same way. So if we have this guy, this triangle is going to be the same and the exact opposite, right? So the x and y coordinates will have the same value. You're just flipping your y coordinate negative. Okay, same thing. If you're trying to find this angle's value, then you're going to go up and find which one fits it. And then you can also go across, and then it's going to have that reference angle of 60. Right? Yeah, so it's like a circle. You can also go directly over and then up and make a big triangle, and that is just a doubled triangle. But it will have the same x and y values, just negatized according to the quadrant. So now what we're going to do is we're going to go through and we're going to find some patterns. Okay, this is where highlighters might come in handy if you're a highlighting type person. So we're going to go through and I want you to highlight every root 2 over 2 you can find, whether it's positive or negative. Just the root 2 over 2. Yep, just the coordinate. how many times do we see root 2 over 2 repeat itself? 4 whole coordinates, so 8 times, right? How many of those are positive? How many of our 8 repeats, right? Because we have 1, 2, 3, 4, 5, 6, 7, 8. How many of our repeats are positive?
2, 3,
4, right? So you have 4 positives, 4 negatives. So of your total 8 of your root 2 over 2 times that it occurs, half are positive, half are negative. Okay, so that's one way that you can double check that you aren't missing one, is it should be an even split positive, negative. Now we're going to go through and repeat that process for all of our root 3 over 2s and pick another color.
Oh no, I'm running out of color.
So root 3 over 2s.
Just the root 3 over 2?
Just the root 3 over 2s. Right? How many root 3 over 2s did you find?
8.
8, right? How many of them are positive and negative? 4 of each. All right. What do we notice? This one's in an x coordinate. This one's in a y coordinate. And then as we go around our circle, what patterns do we notice? We have x, y, y, x, x, y, y, x. Right? Because these two are directly above each other, so the x coordinates have the same length, right? So we have our x coordinates are the same right above each other. So it's going to have that repeating pattern of starting with the closest one to 0, x, y, y, x, x, y, y, x, right? And then the positive negatives, right? Positive, 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 negative, 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 positive. Okay. All right, now we're going to repeat the process for the 1/2s. Pick another color, go through and highlight all of your 1/2s. And we're going to see if this pattern continues. All right, how many of the 1/2s did you find? 8. How many of them were positive? 4. How many of them were negative? 4, right? And again, we see those pairs, right? This time it starts with the y. Y, x, x, y, y, x, x, y. Right?
Does it do that for all of them?
It does it for all of them. They just start in different positions, right? Because if we start here, x, and then it flips to y, y, x, x, y, y, x, right? X, x, as you keep going around. This one starts on the y. So x starts with the root 3 over 2. Y starts with the 1/2s. And then their pattern repeats. They're just shifted off of each other. Right. So we have y, x, x, y, y, x, x, y, y going around and around. And then our root 2 over 2s are always on our 45s. Right? And then our negatives still play according to that ASTC being the positive ones. You can also think of it as which coordinates, x or y, are positive or negative in each quadrant. Okay. Other questions about this guy? Because you're sitting in front of me.
Okay.
Okay, so with the people at your table, Emma, you can go join another table if you want. Find the pattern that makes the most sense to you. Like which one is going to be your starting pattern that you can memorize, and then everything else figure out from there. Right? Because we only have 4 different numbers, right? We have 1/2, root 3 over 2, root 2 over 2, and we have 0 and 1. So we have 5 different numbers for our sine cosine values. And then it's just positive, negatives, and putting them in the right spot. Okay, we're gonna practice a little bit of that with these that got laminated this morning. So you can use a dry erase marker on them. You can erase them as much as possible. We're gonna do a little bit of practice with this. And then there's also a digital version of this on Schoology as well that you can practice up to 20 times because that's the maximum that Schoology would let me allow you to practice it. But that is the unit circle practice assignment that's in there. That is purely for your own practice. It's added 10 points. You get participation for doing it. Okay. Our quiz will either be Tuesday or Wednesday, depending on how we're feeling on Monday. Okay, so it definitely will not be on Monday. Based on how we're feeling Monday, it'll be either Tuesday or Wednesday. Okay, so I'm gonna have everybody come grab one of these with a whiteboard marker, and without looking at your paper plate first, just plain what you know, try to do this, fill in the radians, the degrees, and then your sine and your cosine based off of what you know, and then check your answer with your paper plate. There we go. If you pick one that's not nicely cut out, you also get the task of cutting it out nicely. I did nicely cut out enough for everybody to have a nice one. But there's also ones that I just haven't cut yet. I gotta take this away. There we go. All right, so you're gonna try this and then check your answer with your paper plate. Okay, and then you can move on. You can do the digital version at home. That one is a little more drag and drop. But you can try this, fill it out. The ones that you mix up or the ones that you forget about, those are the ones that you really need to study. Okay, and you can fill this in whatever order. You can do all the degrees first. You can do all the radians first. You can do all the sines or cosines. You can mark your positive negatives first. There's a lot of different strategies that you can use for filling this out. All right, you can check. You have a unit circle in your notes. It is on page 6.2. You have a completely filled out unit circle here, and you can check your answers. This is the same format as what appears on the laminated sheet. It's what appears on the digital assignment on Schoology, and it'll be the same format that you'll do your quiz on Tuesday, Wednesday. Okay. And hence why also we are kind of just going to skip through the notes for 6.2 because we did all of this work on our paper plates, right? We're essentially doing 6.2 through the paper plates, and we will pick back up with 6.3 after our unit circle quiz Tuesday, Wednesday. Any questions for the good of the order? No. Calculator defeats the purpose. You do like sine of 30, cosine of 60, like in your calculator, and it'll tell you.
Oh, it'll give you the part.
Yeah. If you're in math print mode, it will. The reason why we're having this memory thing is just like when you were in algebra 2, if you didn't have your multiplication facts memorized and you were trying to factor, how long did it take you to do that? It took you a long time, right? So this is a efficiency thing, less a me trying to see that you can memorize stuff. I mean, memorization of certain things is good. There are certain things in life you have to memorize, right? Like the fact that the pedal on the right is the gas, pedal on the left is the brake, and pedal on the very, very left is clutch, right? You have to know those things in order to be able to safely drive a car and not crash into a ball of flames.
Much rather do the memory thing than actual problems.
So once we have this memorized, it makes everything else we're going to do for the rest of the semester so much faster so that this is not the part that's holding you up, right? Factoring is faster when you know your multiplication facts. If you're stuck trying to use a calculator every time, that slows you down at this level of math. Calculators slow you down at this level of math.
Can you get the